Hmm. Central Illinois Sirens and CNY Siren Boy, thanks for joining. Oh, the speaker's still going. Oh, I completely forgot about that. And my hash browns are done. I just heard my toaster beep at me. I guess I'm a little bit late. It's almost 10:30 now at this point, at least here on the West Coast. OWS of Kansas, thanks for joining. Why, for whatever reason, the chat box doesn't want to pop up for whatever reason. Alrighty. Well, I guess let's make sure that I have the stuff actually open that I'm going to actually be kind of showing off today. Alright, make sure this is all clear. Everyone keeps texting me now, of course. Alrighty. Because I can turn off this music and really even realize that this has still been playing the entire time. Alrighty. So, welcome everyone that's kind of joining us in now to get a look at kind of some of the stuff that we were talking about and a bit more of the stuff that I didn't really cover in the kind of the video I just posted recently, because it was a lot to cover. The video itself was already running to be about like 18 minutes or something like that in terms of length, and I kind of didn't have a lot more that was really that important that I had to kind of talk about, but I guess this is kind of just that that kind of makeup here. So basically, just kind of just going through it. So there's a couple of things that I have to kind of update in terms of the model itself. I guess I'll go ahead and pitch that down a little bit. There's a couple of things I need to change and kind of update in the model itself that really pretty much just involves cleaning up a lot of the wiring, because as the wiring stands right now, it is messy. So that's one of the things I'm gonna have to clean up and see if I can get conduit boxes and little stuff to kind of clean the wiring up. Um, Saying Hawaii is having their monthly test today. That's cool. Seeing why Siren Boy says any update on the AC alerter. Not much has really changed. Not really much. Not really much has changed on the alerter. I'm gonna probably spend a bit more time relatively soon, just kind of just cleaning up the scale a little bit, because it is kind of oddly scaled. Like the entire projector itself and the donut, if you want to call it that, is a pretty accurate, I think, at least in my point of view. But basically, the only thing that's got to change is just the rear the rear rotator cabinet. But I guess we can actually go ahead and open up my display capture so everyone can kind of see what's going on. But this is just Streamlabs. So I've got another question here. OWS of Kansas, here's my question. How in the name of hell did you get the Roots blower to work? Um, I guess I'll go ahead and I'll explain that in just a second. And then Central Illinois Siren says, is there a way for me to just buy an AR timer? I really want one. Yeah, that's going to be something that I'm going to be doing in the future with the current AR timer. Um, or the current miniature AR timer. It will be one of the things that I eventually end up selling as a standalone. And one of the ideas I pretty much have with the current Thunderbolt model, which you see here, this is basically what the inside of it looks like. If you haven't seen the kind of update video, but that's kind of what the inside of the blower cabinet looks like currently. But my idea with the AR timer was for it to be, initially I had planned for it to be a separate purchasable thing that you can buy to work with the Thunderbolt. So you could, because I know that the Thunderbolt was initially it was going to be pretty expensive, and it might still end up having to be that way just because of how much time it takes to put it all together, including the like hours of soldering to get everything to actually function properly, and then afterwards going through and actually testing it to make sure it actually works. So there's a lot of time that's kind of gets sunk into it, but I do inevitably want to have a separate version of the miniature AR timer that will work with just a standard Siren. It's going to be dual voltage, so it'll be 120 volt to 240 volt operation, so you can use it to power. You can use it to power stuff like Model A's. You can use it to power Model D's, and if you really wanted to, you could actually have it hooked up to power an actual Thunderbolt, like a real one. And it'll have the same kind of connections to basically tap into the RCM to control the contactors and the agostat in like a regular real RCM. So that's kind of what I'm planning for that. So I'm gonna go ahead and actually pull up the live stream right now so I actually can see what's going on, because I can't really see the chat when I have it up on the computer. So I'm just gonna go ahead and just do this really quick. But yeah, the jail bar, you said also in here, CNY Siren Boy says, can you buy the jail bar separately? Well, I am going to actually include the jail bars in the set, basically, when you get the Thunderbolt. So it will have, like I said, it will have a standard grill on it, like you'd see on like the later generations of Thunderbolts, as well as the jail bar, and as well as you can just take the jail bars out, or take the entire grill out and have the thing just like open throat like it kind of is right now. But that's kind of what's going on with it. Let's see if we got anything else in there. But yeah, that's pretty much kind of what I'm planning out for the AR timer, is so that you can basically vary it and use it for whatever you pretty much need it to, and it'll be a universal timer. And then in the future, hint hint, I haven't really talked a whole lot about it. But I will also be planning on making an AF timer with variable high-low, so you can actually change how fast your high-low cycles. Because it's not really that hard to kind of retrofit the current AR timer that I have to be able to control a 1003. It just doesn't right now, because I haven't made a 1003, but that's coming in the future. Just I kind of want to get this whole 1000X situated. And then, so there's the RCM. You guys have already seen that in the video. If you haven't seen the video, but that's what the RCM looks like. And it's actually it's all unpowered right now, so nothing is actually on. Alrighty. So read some more of the chat, and then we'll go ahead and actually dive into what we're doing today. So OWS of Kansas says, which siren are you planning on giving away? I don't know. I don't know yet. I kind of have a wish that's kind of been knocking around in my head, because I'd really like to give away a Thunderbolt, and actually give away the first model off of the production line. So basically on the serial number 1 of the first Thunderbolt 1000X. I actually have the name tag somewhere, wherever I put it, or threw it, or dropped it, because I kind of got a whole bunch of crap on my desk right now. But I actually have a name tag for it, already kind of designed. So it's not going to be saying the exact same thing as like a real Thunderbolt. It's not going to say Federal Sign and Signal, because even though they designed it, I'm designing the model. So it'll have my own custom little deal there. So let me go actually pull up and make the webcam just a little bit bigger so you actually can kind of see. Whoa, I want to move that. I want to move you. There we go. So that's actually what the the tag will look like for it. So that I'm debating whether I want to have it actually on the RCM itself or I want to have it mounted somewhere in the blower. But that is the tag. So that's Cruise Engineering. It's a model 1000, 1000X, and in this case the serial is 01A24. So, and I'll explain kind of how the serial numbers will work with these models kind of going forward. But it's basically the way the serial number works is that you've got your two numbers in the front, so zero in this case it's 0 and 1. 0 and 1 dictates which one it is. So in this case it's the first one. A indicates the series. So if it's, say, if I change some things later on in the future, it can be, say, Series B or Series C, much in the same way of that, like a kind of the way Thunderbolt or the way Federal kind of did it. And then 24 is just the production year. So that's basically how the serial numbers work. But yeah, alrighty. So, but yeah, Alex Sirens of West Washington says I also technically own the only ACA cyclone in Washington State because I got Edon's one from Edon for Christmas. That's cool. So you have like one of the larger cyclones then. Yeah, yeah, the mini cyclone. But yeah. Alrighty, so let's go and kind of dive in. I'll kind of explain generally what I'm doing as we're kind of going through this. And if you guys ever end up actually having some questions, you can go ahead and just drop it in the chat, and I'll go ahead and respond to it as quick as I can. Please excuse if I'm a little slow, because there's probably going to be a lot of chatters that are going through here. Also, I should probably move my mic. Let me try to make sure that that's not like deafening as I kind of adjust where this is placed. I'm hoping that it's not just like sitting in frame. So we'll go ahead and kind of dive in here. So Central Illinois Siren says, how much do you think the AR timer will be? I'm still not entirely sure. It's probably going to be about maybe 150 because there's a lot more components that are going to go into it for it to be dual voltage. Um, it's going to be line voltage controlled, so there's not going to be like a separate little adapter in order to power it. It's basically going to have the same kind of transformer like you'd see in a regular AR timer that will have two taps on it, so you can tap into either the 120 volt primary or the 240 volt tap on the primary, so you can power the siren or the timer with basically just the RCM. So, but yeah. Alrighty, so let's kind of dive in. So I'm going to go ahead and kind of explain what we're doing here. So the current standing issue with the Thunderbolt that I have right now, or how I've designed it, is wire management. So there's a lot of motors, a lot of controls, a lot of wires kind of running around everywhere. Um, as you've probably have seen in the original in the original Siren or the original Thunderbolt 1000X video that I filmed when I was still living in South Carolina. That I think I filmed like almost about a year ago now. When I filmed that, you could see that there's wires running everywhere. Like it was a mess. And I kind of want this siren to be pretty neat, pretty compact, and pretty clean internally because it just makes it look so much better. And that's going to be the subject of today's video. So in this case, we've got some of the basic controls that you guys have already seen before, or some of the basic components that you've already kind of ran through before. So right here, of course, is our gyro cap. It's just a name I gave this component, or my method of basically doing the wind down. Essentially, all it is if you were to actually pop this off, this front case, of course, there's a lot of components, as you can see on my left tab over here. But you open it up, and essentially all that's in there is just a gigantic flywheel. So that is a huge flywheel that's in there. This over here, this gray area that I'm kind of highlighting, that is what I'm calling the charging motor. So the charging motor, essentially all it does is it's taking 12 volt power, and it is just running to speed up this big flywheel. So essentially charge the capacitor. And then this motor over here, well, where there would be another motor, is the generator motor. and that is just there to take power out of that flywheel. Um, in the process, the reason why it uses two motors is because the entire bus voltage of this model Thunderbolt, if you don't know what bus voltage is or what the bus means, basically just your incoming power. So the bus voltage of the Thunderbolt 1000X is 12 volts at about 5 amps. So, but in order to run a lot of the components in here, I don't need 12 volts. In fact, I actually need less than that. So in the case of stuff like the rotator is a 3-volt rotator motor, and the chopper motor sitting way up in here is about 3 to 6 volts. So if I have 12 volts running to both the rotator and the chopper motor, I'm going to kill them. So basically, this gyro cap also does double duty in not only assisting in the wind down, but also stepping the voltage down in order to appropriately run those two components. So, and continuing on here, so just kind of giving you all a brief overview of all the components in here. This right here, this box, which is on the back of the gear case of the blower, is a time delay box. So this box will essentially house the cycle delay timer for the blower itself. If you're not sure what a cycle delay timer is, if you know what the agastat is in the RCM, basically that delay that allows the blower to keep running as the chopper is slowly winding down. So what gives the Thunderbolt its notorious deep rumbly wind down. The agastat is a time delay. Apparently they're a pneumatic operated time delay, or they're the piston inside of it that actually sets your time is pneumatically retarded inside of it, and that's how it basically works. But I know I was under the impression that they were thermally operated, because a lot of time delays that are kind of used in modern PLC controls are usually thermally rated, or in this case they're usually just digitally done. Um, and so since digital PLC controls are pretty easy to kind of get a hold of and they're a lot easier to program, this is going to be using a digital time delay or cycle delay, because that just makes so much more sense and it's much more compact than using a pneumatic time delay. So that's what's going to be housed in here. And if I can figure out where the box is for that, where was it? Oh, that's an air pipe. Where did you go? There you are. So yeah, but yeah, so I got see some people were chatting in the comments down below. So, oh, you guys are talking about trying to get a hold of a siren. Would a 2 be better to get as a first real siren than a bolt? I would say yes. That's pretty easy yes for me. I mean, if you're asking my opinion, especially depending on where you live, like getting a Model 2 is a lot more realistic than getting a Bolt, because the Bolts weigh like what, like 600 pounds for like just I think like just the head itself, like, and that's not including the blower, which is probably another 600, probably 700. I don't know. They're heavy sirens, and they're really cumbersome. So like, even if you have it set up on a cart so you can wheel the siren kind of outside and stuff like that, they are very cumbersome. They're a real pain in the neck to move. I remember trying to help move Edon's Thunderbolt and how much of a pain in the neck that was. But yeah, I'm just going ahead and talk to my wife real quick. But yeah, so that's some of the kind of the electrical theory of how this actually works. I do also have the box for the AR timer, but I'm going to tell you right now, there's not really a whole lot of interesting stuff kind of going inside, like in the model wise for the AR timer, because there's just not. It's basically just a box. All of the really cool and interesting stuff is done electronically, so that's all done through the wiring schematic. Which, I mean, if anyone, this is also another thing I should have told everyone, is if you do end up purchasing the Thunderbolt, then you have it yourself and you need to diagnose anything, or if you have any problems with it, um, I could go ahead and actually give you guys a copy, or the people that end up buying it, I could give you guys a copy of the wiring schematic for it so that you actually are able to go through it and diagnose it if you have such a problem. Um, it's pretty similar to that of the real Thunderbolt or the real RCM, like a real RCM, just with the basically where the contactors or the relays are is just kind of shifted over and kind of moved in odd spots. But generally they're pretty similar to each other. So, um, LOL, it isn't like the Thunderbolts were built for portability. Exactly. Like that's I mean, so if you really kind of want like your first like real Siren, I'd look at something like a Model 2. In my case, I don't have a Model 2, but I do have like three Model Ds. Because Model Ds are my favorite, which I think I've made obvious in the past. How come multi-tone sirens produce less dB than single-tone sirens? It all comes down to airflow and how much you can actually get through it, as well as sound cancellation, like ODBS of Kansas is saying. But usually it has to do with restriction. So I mean, it's really not that hard to figure out. I mean, if you haven't really like, if you take like 5 minutes to kind of think about it, it makes total sense. But essentially, like, well, just look at this. Look at how big that port is on a single tone on a 5 port single tone Thunderbolt rotor. Now look at how big the ports are on a dual tone. See the difference? You're not going to get nearly as much airflow through them, and that's part of the biggest problem. So like when it comes to sirens, it's usually the thing that makes them loud is going to be usually your airflow through them, the maximum amount of air you can get through the siren per rotation or per cycle of the ports basically, and the pressure at which that air kind of comes out. But it's usually generally more of the volume of the air. So that's why smaller sirens just generally aren't very loud, is just because they're not moving very much airflow through them. That's why they can still make the same pitch. That's part of the reason why the Thunderbolt is such a unique siren, or that's why it's such an efficient siren for its age at least, is because of how well it is able to breathe because of the fact it has a supercharger. Um, CSX Enthusiast 870 says, "Is it a limited time item?" Are you referring to like the Thunderbolt itself? Once that's eventually kind of all done and ready to go, or are you referring to like the timer? I really need lunch. I actually need breakfast. I didn't get anything yet. Well, while I'm waiting for that response, I'm going to go ahead and kind of show you what I'm working on now. So, the way you can kind of think of the way that this is set up currently is this is a motor right here. This is the back of our charge motor for the gyro cap. And then this is our generator motor on this other side. And as it stands currently, basically all that it does is that the wires and the back of the motor just kind of stick out. So, like here in this case, this is the blower for the old Thunderbolt, or the old Thunderbolt blower, I should say, just specifically, or first gen. Let's put it that way. And that's basically how the wires are ran on it. So it just pops out the back of the blower motor, and there's the pitch control for the blower speed, or the blower type selector, and then there's the top of the impulse generator. So you see how all the wires are kind of exposed now in the open? I'm not a big fan of that because it just looks messy. Um, it looks very, very messy, and that's kind of one of the things I don't like about it. So since there are so many connections, I'm trying to clean that up as much as possible. But the way that that's basically a good illustration of how I plan on doing that is actually by looking at the AR timer and the RCM. Is you notice how this lead wire right here that's basically coming out of the AR timer just goes and cleanly leads into the kind of selection panel on this side. That's basically how I want to have all of the connections done inside of this. So you notice that I've got these two basically like nipples on this thing. That's basically kind of why it's the same way on this delay box, is because it actually acts as a strain relief for the cord I use. So there's a nipple right here, a nipple right there, and then I'm pretty much probably going to do the same thing on the back of these. I'm going to make another beauty cover, much like this right here, which is basically just to cover up the back power connections for the blower motor. And then all of these holes are the exact same size, so the cable can run through them, and then all the connections are made inside and away from the elements, which is much better. And yeah, for those who are wondering, because I know some people were commenting before as to why I made the blower so small. Well, to be honest, I didn't intend on having a roots blower actually in the final design of the Thunderbolt of the 1000X. Mainly because I didn't like the idea of using a roots blower because they're just not super efficient in this kind of scale. Um, they're just not really that efficient in this scale, and they're really hard to kind of get to work properly. So I didn't really want to deal with that kind of headache, and I was going to just use a standard centrifugal blower, or I was going to make a regenerative turbine blower to run it, maybe even a multi-stage centrifugal blower. And if you're not sure what that is, you can look it up really quickly. But that was kind of my initial plan, and then I was it was late one night, and I was like, you know what? I'm like, I kind of want to make at least a model of a roots blower. So I'm like, let me at least just try it. So then I kind of just started, and then that's when it got fun because it was challenging to kind of get it to work. Because after I made the model, I was like, well, it's cool to have a model that doesn't do anything. It's much more interesting to have one that actually works. And that's when I kind of spent some time actually making the entire thing behave properly. So in this case, let me go ahead and actually clean up. If you guys want to see what the inside of the blower actually looks like, let me go ahead and clean up this sub menu over here so you guys can actually get an idea what's going on. So let me go ahead and get rid of this drive pulley, get rid of the bearing retainers, and then bearing plate. So that's the inside of the roots blower. It's kind of what you'd expect from a Thunderbolt blower, just this standard twin lobe or bi-lobe um, lobe set on it. So nothing super complicated in order to get it to work properly. I did implement some interesting manufacturing techniques in order to get the tolerance super tight because, as many people know, and as I've even stated before on a previous live stream, getting the tolerances correct on a 3D printed part that is done layer by layer, especially when it's something that you need to have timed properly and fit and finish is really tantamount in making sure that it actually functions correctly. It's not really easy to do with 3D printing, but I had an idea of how to do it, and I kind of just went with it to see if it worked, and it worked surprisingly well. And I'll go ahead and actually explain that now. So, let's see what we have in here. OW, OWS of Kansas, definitely a lot cleaner looking than a real RCM. LOL. Yeah, it's actually because a lot of the work that the RCM normally does, that's all fitted in that one little cabinet. A lot of that work I've spread out in this Siren. So like that's why the delay timer sits way over here, and it's also why the some of the other stuff is kind of moved around, just because it makes it so much less cramped inside that cabinet and makes it easier to assemble. Um, let's see what else we got in here. OWS of Kansas, getting the tolerance correct can be a pain in the ass. Yes, it can, especially with these blowers. So the way that I did mine was that if you've actually ever looked at the lobes of a Thunderbolt of a like a Suiterbilt or a Suiterbilt blower, or also just like generally kind of even like a dresser roots or a Veeder root or like one of those blowers or positive displacement pumps more broadly. One of the things that you might not have actually noticed unless you kind of like looked a bit more carefully at it is that a lot of those pumps on the apex of each of these lobes, they actually have a small, very small little flat spot where they basically make an apex seal, like you'd see like in like a rotary engine. except this is a non-movable apex seal. So they do that because if I move the case back over here, is that if this seal wasn't there, the pressure would gradually constrict and constrict and constrict and constrict along this kind of plane that you're looking at. As you see the edge of the rounded edge of the globe and then the wall of the actual case itself, as this gets tighter and tighter and tighter and tighter and tighter, it makes it a lot easier for the air to actually slip through the edge of this. If this wasn't squared off like this and you had just a rounded edge of a lobe, then that means that the actual like cross-sectional space that the air has to jump through to get from the high pressure side of the lobe to the low pressure side is like infinitesimally small because the contact patch is so small. So in order to get away from that, in order to make this actually work more effectively, I basically just copied that from that of the real roots blower, which is why those roots blower lobes use this kind of squared off contact patch, is because it makes the surface area much, much wider that the air has to try to pass around in order to actually seal properly, or in order to actually leak pie. In addition to that, you can't really see it very well in here because in this case this is actually a slightly later version of when I was working with this blower. But on the first generation, the one that's used in the blower currently, these lobes, the contact area on this apex seal is actually, or the length of the apex seal is actually slightly oversized than that of the case. So the way I printed it, if you were to take it right off the printer, these lobes would not fit in this case. They're too big in diameter. So I did that intentionally so that all I would have to do in order to to more finely refine them is I basically just take a little bit of sand, like a sanding block, just like that, and then you basically just glance the top of that apex seal on the sanding block, and that takes off the weird little ridges and layer lines that you get with the 3D print, and it makes it nice and uniform, especially if you use a really high grit sandpaper. In this case, this is like I think like 600 or something like that, or 800. So that it helps to smooth that out to make it a bit more uniform, because the layer lines are also another leak point. So that's one more thing. The other thing is, and this is my favorite thing to do now as of recently with most of my prints that are mechanical, is this silicone grease. Silicone grease, especially with some of this stuff you 3D print, especially with plastic components, is your best friend. It is your best friend, hands down. Silicone grease, pure silicone grease, fixes so many problems. The reason why, for those who are wondering, why can't you just use regular grease inside like the gears or something like that, like use like gear grease or something like that, or a petroleum-based grease, is because since the material that the components are actually made out of is a thermoset plastic, or not a thermoset plastic, a thermoplastic rather. Um, the actual polymer chains of the plastic itself are kind of configured in such a way that they're a bit susceptible to impregnation or intrusion from other petroleum products. Basically, if they're soaked in some kind of petroleum product, or they come in contact with a petroleum product, um, it basically that grease or whatever it is will try to link into the same chain as the plastic itself, the same polymer chain, and it ends up structurally weakening the plastic. So, or maybe not immediately, but over time it definitely will start to weaken the plastic. So I wanted to use a type of lubricant that was going to be really safe for this kind of stuff, and after doing some research and kind of looking through like SDS charts, not SDS charts, but chemical charts and stuff like that, and basically kind of comparing with the material I'm using, I found that silicone grease by far is like the best stuff to use for these kinds of components. So like the rotator gears that are in the rotator cabinet, silicone grease. The phasing gears on the back of the blower, which in this case that's an old model, but the phasing gears on the back of the blower, silicone grease. The bearings that are in there, silicone grease. And the actual case itself, believe it or not, where the lobes are actually sitting in there and flip-flopping around and pumping air and all that kind of stuff and making the siren go boom. I also used silicone grease in that. Um, just a little bit right down the throat of the blower itself. Just kind of just turning it over by hand. Because the silicone grease kind of helps to fill in some of the voids and the imperfections in the actual print to help make it a bit more uniform so it seals better. So that's another reason why I recommend if you start modeling one of these yourself or you're a siren modeler is working on your own stuff, silicone grease is your best friend. And when this siren is actually shipped, when I actually ship out the Thunderbolt, I'm probably gonna include a small tube of grease, um, just for maintenance, just for basically greasing the gears, greasing the rotator, and all that kind of jazz. Just so people know to use this specific lubricant, because I don't want people to use something else and end up wrecking their siren. So, but that's kind of some of the more in the weeds kind of description of how some of this stuff is done. But yeah, that's pretty much the gist of how I got the blower to actually seal so well. It was a lot, not so much trial and error, but very, very careful planning. And I would imagine, like, well, I'm hoping that other modelers end up watching this video and they can use that information in their own projects because it works pretty well. It worked pretty well for me, at least. So I'll go ahead and bring back the rest of the model itself. I have everything turned off right now, so I'll bring everything back and kind of continue with the working on it. So let's see if there's got any other chats in here. Any other comments? Matthew Walker, can you or anyone recommend a cheap, decent-sized 3D printer for someone who hasn't used one before for sirens? Yeah, for sure. Well, I use a Prusa i3 Mark III's. Or is that what I think it is? It's a Prusa. Yeah, it's a Prusa i3 Mark III's. Um, i3 Mark II's. I don't remember. It's not the brand new Prusa, but it's like one of their more recent lines. Um, I use that. It's a little pricey to get a hold of. It's around like $700 as a kit. Um, and then like I think about 800 something or 900 something as a fully assembled printer. But if you were looking to get a 3D printer to kind of just try it out and see how you like it, um, I look at something like an Ender. Ender makes pretty decent printers for what you really want it to do. They do use a Bowden setup, which I'm not a super big fan of. I prefer if you're going to be doing stuff with PETG, which is the material I use, and I usually recommend for people to kind of learn first. Because if you learn how to use PETG, if you learn the hard stuff first, or the relatively hard stuff, like PETG can sometimes be for people starting out. If you learn that first, it gets so much easier from there because you'll be able to understand kind of how each material operates or how it wants to work. And then you'll try PLA for the first time and be like, wow, this is like Play-Doh. But anyway, but yeah, like an Ender, I think like an Ender 3, or I think they're even up to like an Ender 9 now or something like that. But like an Ender 3 would probably be a pretty good starter. If you can find one that is a direct drive extruder, I would probably look at something like that. I'd read reviews, of course, but something like a direct drive extruder is kind of like my requirement if I was going to look at a 3D printer for this kind of stuff because it just has so much more finesse than a Bowden setup. Not that you can't get really great results with a Bowden setup, where you have the extruder over here and then that Teflon tube that runs to your actual hot end. You can definitely get, with good tuning, you can get very good results with that. But I just like the direct drive because it's just tried and true. It makes sense. It worked relatively well. That's kind of what I would recommend. Um, So OWS of Kansas says, so that's what those things on the lobes are. Yeah, so they're apex seals. They're apex seals for the actual lobes themselves to prevent leakage between the high and low sides. Oh hey, look who's live streaming. Car crashes and smashes. What else we have on here? OWS of Kansas. So this is able to live and still be functional? I don't, oh, live outside. Live outside. Yes, so I'm actually designing this to be weather resistant. Not weatherproof, mind you, but weather resistant. So a lot of the, thankfully, a lot of the stuff that was basically on the Siren itself from Federal kind of had that in mind. But that's why like the stuff like the rain cap that's right here is actually serving a purpose to keep rain out of the rotator cabinet. That's why it's got drain holes. There's actually a breather hole coming off of the air tube that goes all the way from the blower up to the Siren itself. That's inside the rotator cabinet. That basically, like I had said before, actually pressurizes the rotator cabinet when the Siren's running in order to help blow water out of that drain hole. Out the bottom right here. And then of course the rotator cabinet or the blower cabinet itself looks just like this wherever I placed it. Where's the blower box? Blower cabinet frame. Blower cabinet frame. There's so many parts. It is like so difficult to like dig through it. There we go. So like that's why like with the blower box itself, I have to make it in two pieces just because of the way my printer's kind of limited. So it is printed in two pieces, but that shouldn't be that big of a deal. But the that's why on this, for example, since I have to basically put it together, there's actually a lip here on the inside to help prevent water from basically sitting on top of the blower cabinet and then seeping through this crack. That's also why a lot of the stuff that you're seeing that's inside the actual blower cabinet itself is also pretty well sealed. More than likely, I'm probably going to actually even end up sealing the cycle delay timer for the blower because I kind of want that to stay dry because it's electronic. But yeah, the blower cabinet itself is pretty much going to protect a majority of all the components in here. I had the first generation Thunderbolt, the red one, the red and black stripe one. I had that outside during a winter ice storm that we had here in Portland, and it survived just fine. Even with a couple of the controllers actually getting wet because I didn't have them in a box. Duh. Even with all that sitting outside, it still managed to fire up and actually work. The only thing that didn't work right was the rotator had frozen shut, so that was interesting. It's the blower itself and the Siren actually still made noise, but basically the rotator gears had just froze together, so it didn't want to spin. That's basically about the only thing that happened to it. So I'd say be wary of it during ice storms, but other than that, it works fine. Bugs might start crawling up into that drain hole, though. Yeah, I mean, they might, but you can actually open the rotator cabinet, so if bugs start getting in there, which might be really annoying, you can always pop the rotator cabinet out and just evict them, basically. In addition to that, the actual drain hole itself is not very big. It's only about like 5 mil, so it's really, really small. So you can basically, unless you've got like, I don't know, like roly-polies trying to crawl into it, like I think it's about the only bugs that are really gonna be trying to get in there. Maybe ants. Maybe ants. Armaturo, what are you doing in here, dude? What are you doing in here? Hi, Condor. On a scale of 1 to 8, how delicious is the Thunderbolt? It's so yummy, dude. You have no idea. Look at this delicious banana-colored Thunderbolt. It's delicious. Or lemon. Whatever yellow fruit you want to choose. But yeah, I mean, so that's kind of some of the small stuff. Um, Additionally, I've actually made the what's it? Where is it? I've actually changed a couple of things in terms of the motor itself too, because I ran into a problem with the first gen Thunderbolt that I was working on, or that I had designed, that I had shown off in a video. And interestingly enough, it was a problem when changing the rotors on it. So when you pop off the stator cap and you go to remove the rotor out of it, I found that it was fine when you would pull the rotor off because the rotor in the chopper is basically just held there by friction alone. But when you go to pull the rotor off, you can pull it off no problem. But it was when you would try to force on a new rotor that the problem kind of presented itself. In that I was routinely blowing the back portion of the motor, the chopper motor, out of the motor, where because this is basically what the chopper motor looks like for those who are not familiar. I think most people are, because it's the same motors that I used in some of my other Sirens. But I would be routinely blowing this back portion out of the motor, and then it, of course, wouldn't spin right. So I changed that up a little bit by actually kind of enclosing the entire motor itself in the air tube so that the back of the motor is basically supported so that you can force the new rotor on and not worry about just basically crapping the back end of it out. So that's another small change that I made, which I'll go ahead and kind of zoom in a little bit on here so you actually can kind of see what I'm talking about. So if I go to analysis, this should split it in half for me so I can better show you without having to take it all apart individually. No, I want to show you the air path specifically. Where's the air path? There we go. That'll show us the air path here. So here is basically the current air path. What the hell is this analysis doing? It's not wanting to cut this in half right. There we go. Okay, that was annoying. Okay, so here's the current air path of the Thunderbolt itself. So if you want to kind of imagine yourself being a little rat in a maze trying to run through this, how the air is basically being flowed into here. So of course the air gets sucked in from the blower, gets sucked through the little intake screen, basically just to filter all the big crap like hair and stuff. Gets passed along the outer walls of the case, or the inner walls of the case, and then gets compressed and blown down the air tube right here. This little path you're seeing right there is basically just for the wires to come through to actually hook into the head of the siren. So that passes through the air pipe with everything else, goes up here. It's on this, the air pipe itself actually sits on this little seat, and that seat basically is just a coupling for the PVC pipe. There's a smooth transition here, trying to kind of keep up the airspeed as much as possible and minimize as much velocity loss as the air is flowing through here, and trying to basically minimize the restriction. So then it flows up this air pipe. There's actually a splitter here. There's the first primary splitter, which is basically just there to basically give me a spot to hook up wires. It looks really, really wide in this shot right here, but that's just because you're actually seeing the edges of all the webbing that's in there that actually holds that center piece that's basically floating in the middle of the pipe. That's what it looks like, but it's actually more like this. I kind of angle it up a little bit. That's kind of more what the profile looks like, so you can see the webbing right there actually holding that piece in there. And then from there, so the air continues on past all that up to the bottom, and now we're actually into the rotator section now. There's some cross braces here to support the actual bottom bearing of the air tube that's the entire siren is pivoting on. And then your the slip ring fits in right there. So that's our slip ring tube. There's looking at kind of our little pill that sits in the middle of the air tube. That's got all the wires in it for the slip ring, all the wires for the rotator. It's all crammed in there. Believe me, that's a pain in the neck to solder together. And then we go on up, and we get past into the actual air tube for the motor. And so air keeps continuing on up here. So now we're into the motor section itself. There's a little nose cone that sits on the bottom of the back case of the motor, basically just to kind of try to help transition that air over and around the motor itself so it impedes as little airflow as possible. And of course, all of the webbing that's in here that I have to support the parts, it's all been smoothed and transitioned to try to minimize air loss or flow loss. And then this is the back of the motor case right here. So this is basically what's essentially acting as retainment for that back shell for the motor, and also basically just to protect it a little bit better. It keeps the grease that's from the motor inside the motor. It doesn't let it just get blown past. And also, if there's any dust that gets shot up the blower pipe from the blower itself, it's not going to get up here and then get trapped in the little tiny bearing in the back of that chopper motor. So that's the point of that. And then of course there's our chopper right there. There's our rotor, and then there's the two ports for your your high and your low that then just go and transition down the horn. So that's basically how the air path works on the Thunderbolt, and kind of what it looks like from my perspective. But I guess continuing on, people, like I said before, people were asking about why the blower itself is so small. The blower is small because I didn't intend for it to be used in this Thunderbolt, and also once I did make it, I realized that I had a lot of stuff that's going to have to fit in this blower cabinet. So, like the gyro cap or the blower delay or the blower motor and all the conduit and all the stuff, or the wiring and all that kind of stuff that ties into it. So I was kind of already taxed for space, and that's kind of why the blower ended up being this size. So it's a little small, granted, it should be about probably almost double this size to be a bit more accurate to like say a 6M Thunderbolt blower, but it's it's good enough. It moves enough air to make the siren make noise, and that's really as far as I'm concerned with. And also, it's decently loud. I think when I decibel checked it at the max blower speed on speed 3 on the blower, I was getting like 116, something like that. But that was like right in the horn, so it's probably not very fair, to be honest. I probably should have taken some steps back. But but yeah. So what else we got in here? So why do I want to see this thing running reverse wired? I mean, I probably could just for the meme and actually just try it out and see what it does, but I think it's still gonna make noise. It's gonna be pretty loud. Interestingly enough, with the 1000, the single tone chopper in it, it's or the single tone rotor rather, it's actually got enough suction on it once it's at a high chopper level to actually cause the blower to spin backwards or to spin forwards as it's pulling air through the air pipe. So it's kind of cool. Um, let's see what else we got here. Most other sirens are mods. Huh. Well, hold on. I'll be right back in just a second. I'm going to go ahead and unlock the door for my wife. Oh, what? I'll be right back. All right. Alrighty, I had to go ahead and grab myself some food, so I went ahead and grabbed myself some hash browns. But I'll try not to be lip smacking as we're going ahead and going through here. I kind of think it sounds best on the lowest speed, has that throaty 6M sound. Yeah, I found that I tried to get it as slow as, I tried to kind of cover the range of the sounds that Thunderbolt can make with the blower itself. So that's kind of why I wanted to make sure that it had a really, really low speed like a 6M. Even if it was going to be quiet, at least it would kind of make the sound of it, which is super cool. Um, and then all the way up to like a more modern, like the later generations of Thunderbolt with the really fast little ripper of a blower. Um, what else we have in here? So it says, what does he say? CNY Siren Boy says, will the other rotors be sold in the bundle when you release it? Well, when I release it, I'm actually going to be, the rotors will be included for each pitch. So it'll have the 4-5, it'll have 4-5 single tone 5-port, and then it will also have 5-6. So those are the three combinations you get in the box when I ship it out. And then the only thing, and then if you want to have like a custom port ratio, which I might do in the future, like you want to do kind of like a custom thing, um, that'll have to be separate. You can like message me or something like that, and I'll go ahead and try making you one. But no promises if it sounds good or not, because it might not, for all I know. So keep that in mind. Alrighty. So the first thing I'm working on right now, kind of what my idea is for this, is because I want to have one kind of cabinet that does a lot of double duty. So kind of what my idea is since the gyrocap charge motor is pretty open and most of the wiring is going to be going directly there anyway, I figured that what I can probably actually end up doing is I can actually have this little cutout in the back of this cabinet that goes right to the motor, the charge motor of the gyrocap, so that it's all the wiring is right in there. And it also helps protect the gyrocap's charge motor. It makes it look just a little bit better than it would be if it was just exposed like it currently kind of is. So I'm kind of, but the only way I can do that is if I either move this box closer, if I move this cabinet a little bit closer to the motor, but then it moves me away from my mounting holes, which I have right here below it, which you kind of can't see unless I do that. There's actually mounting holes below it for the cabinet. So what I think I'm going to end up doing is I'm going to make a sleeve. So I'm going to actually come here, cut this out, and just cut a hole for making a sleeve that can actually extend the whole way back, because I think that'll just look a lot cleaner. So in this case, how big is this? This is how big is it? That size? So it's 28.2. I kind of want the sleeve to be maybe about 2 millimeters thick. That's generally kind of what I make my sizes of all my stuff, is about 2 mil. So 28.2, so I'm going to need to make this whole 28, or about 30.2 plus another 0.2 for tolerance so that it can slip in and out. So it's going to have to be 30.4. So we'll do 30.4. That should give us more than enough room for the sleeve to actually slip in there. So we'll go ahead and do that, and I should be able to cut this like so. So we'll go ahead and cut that. That's going to definitely open up the back of this just a little bit, which is fine, because here's my idea. So we're going to take this now. Now I'm going to actually make the sleeve, and I know the exact diameter of this piece right here, so we're going to go ahead and, I think this is like 20, still like 28.2, something like that. 27.6, what? No, you're not. You're 28.2. There we go. So that line disappears now because it's lined up perfectly. No, 28.2. Fusion has been really frustrating me recently because it's just been playing stupid for some reason. So 28.2, that gets us out. And now we can do the 30.2. Why is Fusion like being so stupid? It's like not registering my numbers. It's starting to piss me off. 30.2. There we go. Okie dokie, so that's going to give us the actual sleeve itself. As you can see, you can scoot all the way back, and it's going to scoot basically right up against the wall of the gyro cap, so that it'll also, I think it also like unintentionally will offer some support to the gyro cap, because since that flywheel that's in there ends up gets ripping at like, I want to say like around 6,000 RPM, probably a bit more than that. That like, I want to say about 3 ounce to 4 ounce flywheel. It doesn't sound like a lot, but there's a lot of energy that's stored in that little rotating flywheel. So that's why it's all housed in here. But any little bit of imbalance on the flywheel, you definitely feel it because it rattles the crap out of the entire blower cabinet. And that's why in the video of when I was testing it, you actually can kind of hear when it's winding up, you actually hear the gyro cap over the chopper because of how much the gyro cap just vibrates a bit. So it's not by any means quiet. It's not by any means quiet, but it's also not that big of a deal. So we're going to go ahead and move this all the way over here, because when the blower cabinet's actually closed, the gyro cap's really not that noticeable. Like the blower is louder than the gyro cap is. So we'll move it all the way over there, get it pretty close. Get her pretty close to the end of that. Even another thing I had been considering doing, I actually considered having a small separate hole coming out of the air pipe from the blower, and actually using a little bit of bleed air from the blower itself to actually go and purposefully have like little tubing, like little lines of tubing that will run to like the charge motor of the gyro cap, or the generator motor of the gyro cap, basically just to continuously, when the blower is running, blow cold air over the motors to keep them cool. But I found after actually testing it that the motors don't really get that warm because they're well within their rated voltage, and they're also still well within a reasonable duty cycle. So I haven't really found much of a problem with them getting hot. So I ended up scrapping that idea, and it's just another step basically to kind of go through in order to make it all work right. So if it's another thing I have to do, I'd like to try to keep it as simple as I possibly can. So I'm going to go ahead and expand this and give this sleeve a little lip that I don't really need to have extend a whole lot. It's basically just needs to be enough to stick out and actually grab onto that motor. So I'm going to move her to about right here. And we can go ahead and press pull this to bring this actually out. Like, shit. Like so. So it's only going to need to be about like a mil. It doesn't need to be a whole lot. Oh, I clicked join. No. Don't join that. Don't join that. Join this. Love you, honey. That's my wife. You guys have probably haven't seen her in a while. It's been a long time since I've done a live stream. It's been a long time since I've done a live stream. But so now that I've got that, I can actually go ahead and go in here, remove this cabinet itself, so I can actually join the lip to the sleeve I'm talking about. And that's the sleeve. So that's the little motor sleeve I'm talking about. So that will be a separate piece that I'll inevitably have to install. But that's going to be basically just like that, and then I'll probably glue this back lip of the sleeve into this cabinet, basically just to hold it there. And if there's ever a problem with this, you can always still take it apart. So there's all these mounting screws down below, or mounting holes for all the components. So that's one of the other things that's nice about this model, is that it's different from my traditional stuff where it's all been glued, screwed, and tattooed together where you can't take the whole thing apart. This one is different where you actually have screws. If you need to get into the blower for any real reason, which I don't really recommend opening the blower, because it's all compression fit. Everything in all the shafts and all the pieces are all compression fit in there. They're all shrunk fit, so you really kind of can't get the blower apart anyway. Um, Other than maybe enough just to kind of reach in there and get some crap out of it, but that's basically about it. Um, but a lot of the stuff in here is all held together with screws, so if you ever do need to service it, or if you can't service it and you need me to service it, I can get into it again. So it's not all hermetically sealed like my first sirens kind of were, which is nice, so it makes it a lot more convenient. So now I need to kind of figure out where my holes are going to go for all the wiring. So in this case, this siren is going to be using a barrel jack as the main power supply coming in, as again, this thing uses 5 volts, or uses 12 volts at 5 amps. So that's the barrel jack that I usually use. It's about, like, I think 5 mil around, 5 or 6, give or take. And that's going to have to plug into there somewhere. So, as well as the timer, because I have to have the timer, all the timer plugs on it too. So the way the timer is going to work is that the timer is going to have a 12 volt bus right there. That's our basically our plug to join the timer to the Thunderbolt itself. That's all that that's doing is sending power to the timer. That's not sending any. That's not so. That's just basically powering up the timer circuit, powering up the lights and everything in there. That is not sending power to the actual control to actually control anything on the siren. So the control terminals, the control plug, looks like that. That's a very, very small MR30 a mass plugs, but it's a very, very small MR30 plug. So there's going to be an MR30 and an XT60, probably stacked somewhat like that. So of course you're positive, negative for the large plug, and then you've got blower, rotator, and the chopper for the small one. And that's basically all that it's really doing. Um, but that's just there so you can basically disconnect it and basically take the entire thing apart and kind of break it down if you need to move it for whatever reason. It also makes it really convenient if you want to have it in kind of like a mobile application where you have, like, say, a car or something like that, and you want to just plug it into a car. Um, Another thing that's kind of cool about it is that since it's 12 volts, you could have it be battery backup. The whole entire siren could theoretically be on its own dedicated battery that's always charged so that the siren always has battery backup, like you'd see like on a 2001 DC, or even some like the T1, like I think T128s do that as well, or Eclipse 8s. Like you can all have the same thing that you'd have with regular modern sirens. You can have with this siren, but it looks like an old school one, and it basically works like an old school one too, which is really cool. If they were ever going to modernize a Thunderbolt, that's probably one of the things I would probably recommend Federal tries to make sure they implement, especially with modern motors and stuff like that. All right, Matt. I'm gonna have to head off a bit for a game session. Thanks for the info and have a good stream. Can't wait to get one. And of course, of course. Can you make an HOR Super Cyrex 15 from Ohio, a 7 and 10 port? Um, that'd be kind of fun, honestly. A 7 and 10 port would be really kind of cool to hear coming from a supercharged siren. So I might actually try that. I might give that a whirl. I think Snowcube actually recommended I do that too at some point. Lights of Lynn Sanity. Hi, Connor. Alrighty, so now my initial plan with the plugs. I'm sorry, I am eating, so I'm kind of chewing. I'm trying to kind of keep my mouth away from the microphone so you don't hear like the lip smacking. But I think my plan with this instead is because originally what I wanted to do was actually make a specific plug, kind of like this actually. Wherever I keep dropping everything. Well, I didn't drop that. That was my wife that dropped that. But where's my plug? There it is. I hid it from myself for some stupid reason. But initially I was kind of designing my own plug ends for the cables because I think it just looks a bit cleaner than using heat shrink. So basically the plugs for the ends of the connectors would look like something like that. So it has the actual plug itself housed and retained, so that it just kind of keeps it all kind of clean. And I think I still want to kind of keep this idea because I like the way that this looks. Um, However, I'm not going to be doing that for the plugs that are going into the siren itself or from the blower cabinet because it's just too much space. It's too cramped. So this big flipping plug end on the end of it is just not really going to be able to fit into the blower cabinet very well and then be set up correctly. So I'm like, I don't know. So I'm probably not going to end up doing that. But we'll kind of see as things advance a little bit and as I kind of change things. Um, Another thing that a commenter suggested, because currently the way that the blower is actually set up is the vent for it is right here in the front, which is not accurate, I guess, technically to what type of blower this is, or what type of blower cabinet this is. This is a later series of Thunderbolt. But he had suggested that I could probably make a blanking plate that basically slides in there and kind of covers up the vents to make it look like a or earlier generation, and instead have the vents on the bottom so that it can basically breathe from the bottom of the cabinet like most Thunderbolts actually work. They usually just have meshing underneath it. But in this case, I didn't really want to do that because if people end up mounting this on the ground and say they mount it in a sandy area or something like that, I don't really want the blower to kick on and then cause a negative pressure in the blower box where it's basically vacuuming up whatever's on the ground that it's sitting on and then risking pulling that into the blower cabinet and that kind of stuff. And then I also don't want to risk it when it comes to people using maybe like a leaf blower around it if it's mounted permanently. I don't want a whole bunch of crap getting stuck in the blower if the pickups are on the bottom. So I'm going to leave it the way it is currently. I might include a little hood that goes over the vent to protect it from like rain and dust and that kind of crap. Basically just as another safety step. But the actual case of the blower itself, if you look on the bottom of it, it's all very well sealed, with the exception of here for the power connections. But a lot of it is pretty well sealed to try to protect a whole bunch of crap from getting stuck into it, and that's because I kind of intended it to be outside. Um, so yeah, just one of the things to kind of consider. Um, CNY Siren Boy says, do you have plans on either making a T128 or P10 or a Banshee? Yeah, in the future, I'll probably end up doing that. I think one of my next projects after the Thunderbolt is maybe changing up a couple things and making it a 1003. And then, which is, I don't think is going to be really that hard to do. I'll basically keep everything the same down here, and really all that's going to change is just up here, and maybe the wiring running up to it, because I'll need to have a couple extra pins for the solenoid. But my next big project I think I really want to try tackling at some point in the future is I want to make a Yamaha siren. More specifically a music siren. I want to actually do that and make it work all mechanically. It's not going to be air operated like the real one is, where they have pneumatic cylinders to move the shutters for each one of the stator sets. But I'll probably end up using servos or solenoids to actually control the dampers or how they actually actuate. But I think more than likely the next, because I like challenging sirens, and I mean a Banshee isn't super challenging. So I mean I like the mechanically complex sirens, which is kind of why the Thunderbolt's been a lot of fun to work on. So, but yeah, next siren I'm probably going to make is most likely going to be a Yamaha siren or a music siren. Most likely going to be based off the first generation, because that's realistically what I see being the easiest to do. Not so much the later like cabinet styles from like the 80s or 70s. Hmm. Okay. So, how big is this over here? This is like 5 point something? Yeah, 5.75. So, how many connections do I have to have? I have to have 3 connections. I have to have... No, because blower is going to be coming in... no. I actually have to make another one of these boxes. I have to put one on the other side of the gyro cap in order for this to work right. So, because I'll need main power, so that's one plug. I'll need bus power, we're going out to the timer, that's another plug. And then third, which is the actual controls for everything. So I need three of those little nipples or strain reliefs on the end of these, basically to hold this all in here. So that's going to be a little challenging because I don't think there's a whole lot of real estate I have here to kind of work with in terms of the wall. And to fit three of those little things in there is going to be not super easy. So I'm not super excited about that, but we'll try here. So 5.75 is what the width is of that. I might actually be able to. I got an idea. I'm going to stagger them. So I'm going to do 5.75 right there. I'm going to do, and this doesn't have to be super neat because it doesn't matter. It's going to be all cleaned up on the inside anyway. So I can actually go 5.75 for the first cable. I'll do same on the same plane as that, 5.75 again to make another one. That kind of irritates me that these are probably not actually the same distance away from the edge of the cabinet, but cry about it. So you know what, I'll actually make sure that this one is. I'll make sure it's clean for the people that have OCD. Yeah, I'll go all the way to the bottom of the cabinet. Why not? Why not? There we go. And that is not lined up straight, Fusion. I don't know what you've been smoking, dude. And I saw the 90-degree angle. Yeah, why are you doing like 90.3? There we go. That's what I wanted. Alrighty, so now we can go ahead and actually put in another circle right about right there. Whoa, way too big. 5.75 again. So that gives us 3 connection points pretty much for us to actually tie into. So go ahead and extrude these so I can actually have holes there for a lot of my wiring. Just like that. Now really the only kind of concern I have is that those are all pretty close to each other, which means it's going to weaken the cabinet in that spot, which is not super cool. So yeah. Streetlight Robic says hello. I think you meant to say, is this supposed to say Roblox or is it actually supposed to say Rubik? Either way, hello. But we'll go ahead and kind of continue on here. So I need to go and make some tubes here. So I usually make these only about like a couple mils, about 2 mil. So 5.75 plus 2, so 7.75. That is 7.74. There we go. Do the same thing here. 7.75. Just so that to make sure that the walls of these tubes are 2 mil thick. Just like that. We can go in here, press pull, grab those, extrude those so we can add some tubes to this, just kind of reinforce it so that the cable actually has something to grab onto rather. And boom. I don't need to have it come out a whole lot. I learned from my mistake last time where I made it way too big. And I don't really think there's going to need to be that much in terms of cabling. So let's make about 3 mil, just like that. And then the easy part, which is the fillet tool, we'll go ahead and make those little teeth I was talking about. Just like that. Oh, whoa, Fusion had a bit of a stroke there trying to figure that out. It's because they're not even, and also because this is starting to get close to that edge. That honestly should be plenty. I think that's gonna be plenty. Yeah, we'll say that's good. We'll call that good. So I like doing that because it reinforces this edge so that if it was just a tube coming off that trying to grab this cable, if you were to take this cable and like bend it up or down, there's a very good chance that you would snap that little tube portion off of the actual cabinet, and basically just like break the layer away, which is not something I really want it to do, especially if it's supposed to be a cord restraint. So by filleting the edge like that and tapering it up and making a nice smooth transition, there's a lot more meat there on the plastic to hold on to the cable, so it basically is a lot more stronger. Or wow, that was vocabularily complicated. I don't know if that's even a word. But there we go for that. So it's got our 3 connection points. Now the one thing that kind of sucks is that that's not allowing us to, because basically the power for the chopper is right there. So that's going up the air tube that we saw earlier when we were looking at the air path. That's where the cable goes for the head. So I need to have some way of having the power come out of here, take power from this cabinet so it can run the rotator, while simultaneously running to the cycle delay, while also coming from this. So I need to put another one somewhere, but it can't be right there because I have to have it go out the back or something. So I guess what we'll end up doing for that, to make that kind of nice and neat, is did I put a hole there for cable relief? No, I didn't. That and the tensioner for the blower motor's in the way too. This is the part that's like, this is the kind of the really annoying engineering part of it, is trying to figure out how to kind of make it all work together, because like I said, everything is so crammed in this blower cabinet. Like there is not like an inch worth of extra space that's going to be utilized on this thing. That's not true. There's actually kind of, now looking at it, there's actually a couple of spaces. Um, Getting one from Edon. What are you getting from? What are you buying from Edon? SPC Franklin 1026 or 1062. I know he's got a couple of new models out that he's had out for, I guess, like a couple months now at this point. But yeah, what's your selection? What are you gonna get? You know what I could do? Is I could put that right here down low. Yeah, I could put it down low. Yeah, I could put that wire down low, so it basically just pops out right here at the bottom, and then goes right along the foot of the gyro cap and goes into the blower delay, and then powers the blower, of course, which means I actually have to have two, because I have to have power for the gyro cap, power for the blower. Hmm. Hmm. Well, no, one of these wires, because these wires are 6 conductor that I used. So these are the wires. This is the cable that's used for the Thunderbolt. So this cable is 6 conductor. So you've got yellow, black. You've got no, you got red, black, yellow, green, white, and then orange. So on the way I'm basically using is I'm using like 5 out of the 6 conductors, and then orange is an auxiliary. Orange more than likely will be used for something else. I'm not sure yet. That might be saved for the 1003. That might be the cable that actually runs the solenoids, because I'm only going to need one wire to do that. So that might be what that's going to end up doing. But I'm not entirely sure yet. So it looks like so that's going to be all housed in those conductors. It's going to run in, take the bus power to the cycle timer, as well as the power that's outgoing for the blower motor itself, and then the other 2 wires are going to carry the signal wire from the RCM, or the AR timer, to actually activate that, because this motor draws about the most amount of current of this entire Siren, even more than the gyro cap, which is surprising. So I don't want any power being handled by the AR timer directly, especially because the AR timer is meant to be mounted kind of far away. So I don't want direct like switching power running through that timer, because then you're going to heat those conductors up, and it's not super efficient because you have to deal with the resistance of the timer wires. MSP, what are you doing in here? MSP says, hey all. Yeah, I'm glad you were able to join. It's kind of gone over a lot, so if you haven't gotten it yet, you probably have to watch the upload once it's up here on YouTube. But we're just basically going through and kind of cleaning up some of the wiring on the Thunderbolt and kind of getting an idea of how the cabinet situation is going to look in terms of what it's going to look like when you open up the blower cabinet. So it's been kind of a lot to kind of toy around with right now. I might I might even actually put another one of those pass-throughs for the strain reliefs in this cabinet as just like an extra one, just in case I need it in the future, because I don't really I think I only need 4, but I'm gonna put one there anyway because I might be wrong. So let's put another one over here so it's the same diameter, 5.75. That's 7.6, moron. 5.75. There we go. So we'll put one there. I want to stay along this same kind of path here, so I'm going to go move out a little bit. That line. There we go. Let's move out 10 mils. Put one there, and then we'll go ahead and do another 5.75. So another one right there. So there we go. So we got 2 more that are coming out the back. They're coming out at a bit of a further angle too, so it might make it a bit easier for the stuff to kind of all run together. I'm kind of worried though. I don't know if that's actually the right size or not, because that might actually be too small. 5.75 might be too small for this cable. I don't remember. I know one of these through holes I have on here is the correct size, but I don't remember which one it was. I think it might be actually the through hole for the cable for the head. So what's the diameter of that? Is it 5.75? That's 5.70. That's actually smaller. Hmm. I'm not seeing it. I don't know where that hole is. Alright, well, whatever. So we'll go ahead and do the same thing as that one. So we're going to go ahead and make this go out 2 mils. So 7.75. Fusion, you can cooperate with me today. So 7.75 like that. Boom. Same thing over here. 7.75. Just bring this out a little bit, just so it has some kind of meat for the cable to grab onto. And we'll go just like that. I'm only going to bring it out about 2 mils. It doesn't have to be a whole lot. I don't want a whole lot sticking into the cabinet. We'll join that. Do the same thing as the other one. So we'll go and fillet these edges to make our pass-throughs, which it doesn't like that for some reason. Even though you should, because it's pretty close. Hurricane says, hi, Connor. How's it going, dude? Thanks for joining the stream. I guess I can only go about 2 mils. That's fine. It just needs a little bit just to basically hold it so it's got something else to grab on there. And this is not really going to be a point that's going to be disturbed a whole lot, I don't think, because it's internal. That's just internal wiring, whereas this stuff over here is going to be regularly kind of moved about, plugged into, unplugged, and that kind of whole deal. So that's kind of why I want these to be a little bit thicker. I guess I probably could have made the made the pass-throughs on the delay timer a little bit smaller too, but whatever. So yeah, this I don't really know quite how I'm going to do the gyro cap. I think I might, because I do have to put a speed controller in here somewhere for actually controlling the speed of your chopper motor. And for those who were wondering how the delay works for the chopper too, or for the rotator motor rather, because I only have one cycle delay timer, and that cycle delay timer is for the blower. It's not for anything else. So I believe on the Agastats they were actually two. You've got basically like 2 taps on it, so 2 different timing sequences, so that you could have basically as the siren cut off and the Agastat went into its basically its timeout feature or its time on feature. That's what let the blower continue to run. And then after that dropped out, then they would also cause the rotator to drop out. I think the way they had it ran was they had a separate tap that ran over to the rotator contactor as well. In this case, I don't have a separate relay for the rotator, so the way that this actually works is that when you hit rotator on the RCM, so if you go in and you actually just you select manual control, and then you select rotator down here, it will basically like just directly send power straight to the rotator, and that's all it does. When you actually have it working in automatic though, and it's under automatic control from the AR timer itself, the way it works then is that the rotator motor itself and the rotator speed controller is getting its motor actually from the reverse side, the generator side of the gyro cap. So the gyro cap, once the gyro cap is spun up, it will be generating roughly around like 6 to 9 volts, or 3 to 6 volts, basically for the chopper motor, and it actually taps off some of that voltage, or taps off of that, and actually runs to the speed controller for the rotator too. So that because the rotator takes basically like no power at all. The rotator is super like light on power consumption. So when it's running, as your chopper starts winding down and the gyro cap is slowing, it's still sending well more than enough power to the rotator to keep the rotator's speed controller awake. So the rotator keeps spinning exactly the way it was as the chopper's winding down, and it's only when the chopper gets to almost a complete standstill that there's not enough power to keep the speed control circuit for the rotator alive, and it drops out, and then that's when it shuts off. So, I mean, I'll probably show that later on in some other video or something like that, but that's pretty much how that works for the delay. So that's why this delay box over here is just for the blower. That's the only thing it's controlling, is it's just the blower. So, and I have it set for I think like 5 seconds or something like that, or no, 7 seconds. So that means if you hit the test button on the AR timer and you have the blower switch selected for automatic operation, or you have it actually turned on, it's gonna, even if you tap the button for a second, it's gonna run the blower for about like 7 seconds. So it's like get used to that. If you're like, why won't it stop? Why won't the cancel button shut the blower off? That's because it's on the agistat, or it's on the timer, or it's on the cycle timer. I'm moving to the 23rd. I'm moving on the 23rd to Ohio. There's an inactive SGH-10B in my town. I want to see if I can get it. That'd be super cool. That'd be super cool. Yeah, SGH-10s are fun. I've had a couple of people that keep asking me to when I'm gonna make one, and I'm like, believe me, I could make one pretty easy. I just don't want to because they're just simple. Like, I don't think they're really that like interesting, you know? They're not like super mechanically complex. So it's like I don't really see what's interesting about them. I mean, of course, if it's someone's favorite Siren, I understand. Don't get me wrong. I also think I'm like one of the not to like humble brag. I don't really think I am, or like trying to be unique here, but I think I'm also like one of the few people in the community that like their favorite Siren, bar none, of all time, is like a Model D. Like, it's like, it's like saying if it's like if someone asked you what like your dream car is, and you're like, oh, if I had all the money in the world, man, hands down, my dream car, a Celica from like 1990. It's like, it's people will look at you kind of funny. Or it'd be like, yeah, my dream car is a like 98 Honda Civic. It's like, okay, that's a choice. Like, really? All the money in the world, you chose a 98 Honda Civic? I don't know. Yeah, I'm just kind of reading through some of the chat on there. But my throat is killing me now because I've been talking so dang much. But I think this is kind of a good starting point for kind of where we want to go. I also think that, like, and for those who are wondering in the stream, kind of like, why is he mainly talking and not doing a whole lot of modeling? Um, Believe me, I usually use these live streams kind of as a way of better connecting with the community outside of outside of like professionally editing a video together, and like kind of getting it all together and getting all the clips I want and kind of editing the sound and making it funny and having memes. Like all that kind of stuff is like time consuming. Um, Whereas some of the times I just want to reach out. I want people to be able to see my thought, like hear my thoughts without having to have it all scripted out or something like that to, recite. That's kind of how I think about it. And this allows me to do that pretty easily. Yeah, I had to change that because I didn't put the line in the right spot. I wanted to put it over here. I don't know why this thing keeps trying to pull for this origin point. I don't think that was my origin point. But I actually, in saying that, probably won't actually keep streaming for very much longer because I think I've just about talked about all I really wanted to talk about. Believe it or not, I know. Connor talks so much and doesn't say hardly anything because half my talks are usually rambles. We still have 7 people in the chat. That's still cool. So I'm gonna make this about 3 mils out from that line. You'll see what I'm doing. You'll see what I'm doing in a second. I'm basically just putting in retaining screws because I want to be able to get in there and then wire it up and then inevitably find out that I wired it up wrong and then take it all back apart again so I can fix it. So that's pretty much what I'm doing here is I'm basically just going to be putting in mounting bosses for screws so that I can actually get back in here. And that's all that I'm doing right here is just making these standoffs right here. You'll see kind of what I'm going to do. So 3 mil. Man, it's windy out there. It'd be a good day to test if it wasn't so freaking cold out. Actually go to the park and test the Thunderbolt. So, there we go. And now I can actually go and make the circle I want. So 6 mil, it's definitely gonna be overkill, but no kind of kill like overkill. So put 6 mil there, put another 6 mil over here. That's gonna give me my circles, basically my corner points. And I can either choose to support this or secure this with M3 screws like I did for everything else in this cabinet, but I'm more than likely going to use my little tiny little boys here, which are like not even a millimeter. I think they're about like 2 mil length self-tapping screws. Super tiny, super annoying too, because they're very fiddly. For those who are wondering, my RC jet boat uses those screws to hold on the bowl on the back of the jet pump, and I really wish I had thought of something else because it's really fiddly and annoying when you're trying to change it. And also the screws are like mild grade steel, so they rust really quick. So I don't really know if I want to use those screws for this, which is why I'm kind of going overkill with the 6 millimeter standoffs, because I think that's probably going to give me plenty of room if I do want to change it in the future and actually make it use M3s. So let's make sure, is that going all the way to the base of that? Yes, it is. Okay. I actually probably don't need to go all the way to the base. I'm gonna go about about 5 mil. Join it there, so that's joined now. And then now I can go in from the crap. I need to cut this in half now. So I'll go up here, go to inspect, go to section analysis. I don't know which section analysis that just pulled up, but we're gonna go ahead and do this. Just so I can see, where did you go? There we go. So now I can see the actual back side of this without having to take everything apart. Or get like in a funky position. Sketches, what sketches does it have open? What? There we go, get rid of that. That's gonna be my way if I didn't get rid of that. Okay, so now I can go in here and kind of clean up these edges. So if I go here, let's do fillet. I'll try to fillet it. It's got a weird kind of profile. So I don't know how nice the fillet tool is going to want to play with this. We'll try it. What in the world? Okay. What? What? Why'd you go in? I guess it makes, yeah, well, okay. I mean, that actually doesn't look that bad, so I might actually use that for all of them. So we'll do fillet that edge too, and we'll just go ahead and copy that onto the other ones too, just so we can kind of clean these edges up. because I want this to be printing with the back portion that you were just looking at. I'll show you in a second. I want to have that back portion flat on the plate, but these little standoffs are going to be basically floating in the air, and I have to make sure that they can be printed. So I'm going to be adding these fillet pieces here so that that transition as that goes up to this piece that stands out in the open is nice and smooth transitioning over to it so that this part can print basically almost like midair because it's been slowly built up over time. So that's why I'm actually adding these little fillets if you were unsure about that. For those who just kind of don't know that trick, that's basically what I'm doing with that. It should be pretty common, but if you didn't know that, that's what that's for. So there we go. So now those are all filleted. Like yeah, there we go, cool. So I'll go ahead and save that. Fusion might have a stroke trying to do that because it doesn't like doing really complex computations like that on this computer, at least. Sometimes. Depends. But yeah, so I added those little fillet edges like that, just like that. That's a very common thing to do on prints that are going to be a little difficult that have overhangs. So I did it right here too. You can see, oh, well then why is this part still sticking out? It's because you don't need it all the way. You only need it for a certain point, and then there's enough plastic there that you can basically print midair because it's not moving super far. So that's why I just didn't even bother going up all the way. Some people call it lazy, I call it futile, and or I call it resourceful. So I hope it doesn't 912 3T21. I hope it doesn't sound like I'm insulting your modeling, but this horn is but is the horn going to get redesigned in the final version? Probably not. Probably not. Like I don't really see there being that much of a problem with the horn. Like yeah, it's not exactly like what it would look like on a real Thunderbolt. I think like the real Thunderbolt would not be nearly as wide. It'd be a bit longer, but in the sake of keeping it just a little bit more compact, I've just left it the way it is. Like it's already so close that I'm like anything else other than trying to get it like absolutely perfect is just a nitpick at that point. But like and I don't mean that to be insulting. I mean it just like I don't know. I just really haven't found much of a reason to try to go through and like this trying to model the horn itself was already enough of a pain in the neck the first time, and I don't have any actual measurements to go off of for my scale, so I just was doing that all just by freehand. Man, my throat's getting screwy. I need a cough drop. Be right back. Ugh, where's my green cola? I didn't expect my throat to get that sore. Yeah. So it's still just a lot of cleanup, basically. Like what I want to kind of do. This is going to be a really kind of busy, busy electrical cabinet, so that's going to be fun. That's going to be fun to solder and assemble and do all that for. But we're running at about 12 o'clock now. I think this is probably going to be about it for this brief little live stream, but I really do thank everyone for kind of joining in and getting to kind of tool around and look at what we've been working on and answer hopefully some of your questions have been answered, some of the bit more in-depth questions. Um, I guess briefly before I take off, some of the things I can kind of talk about because I was going to do a separate video on it on my main channel that basically goes over a lot of the maintenance that I'm kind of expecting to have to perform on the Siren. I guess I can probably do that now at the tail end of this live stream, just so people kind of have an idea of kind of what goes into it. So, start with some of the easy stuff. So, of course, like I had mentioned before, this is your intake filter for your blower. All I recommend for this is that you keep this clean. Basically, it's just friction fit. It pops right off of it, and you can just take that, run under some warm water, blow it out, and then plop, just put it right back on top. So that's one thing. I guess, like I said, we're getting near the end of the video, so I just wanted to kind of give you guys some brief more extras. The belt itself, so this is using, like I said, it uses a standard hair tie as a belt, at least currently. In the final, I'll probably more than likely use like an EPDM rubber O-ring or something like that. Um, or some type of other belt material that's a bit more durable and has a bit more grip to it. But I basically chose a hair tie because it was convenient because my wife has 1,000 of them. And yeah, and it worked relatively well. The one thing I don't like about them is that they use natural latex usually in them. So eventually over time that latex is going to rot and it's not going to hold up very well. So the belt will lose tension. You might notice that the blower doesn't have nearly as much back pressure on it like it normally does. And your siren consequently isn't nearly as loud. So that's going to probably change in the future. Which I mean, I've already pretty much intended it to. That's why the motor itself, if you notice down here, the motor itself has this little boss on the end of it, and there's actually this plate that goes right here. And if you've really kind of paid attention and use your noodle, the motor itself right here is hmm, 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 hmm. Huh. Well, it won't let me do it from here. But basically, if you notice, this motor is actually on a sled. So the entire motor is on a sled. There's actually supposed to be a screw that goes right here. And that allows you to basically tighten this down and actually scoot this entire motor over to tension it. So that's pretty much what that's supposed to be for. So I've already planned on not really using a hair tie in the future. In addition to that, so keeping stuff lubricated, I'd recommend probably not trying to lubricate the blower internally. Don't try to lubricate the lobes. I do that once, let it wear in, and then basically call it good. Um, However, the silicone grease has a very weak glass point, where it'll eventually, or not glass point, but it's like ductility or tackiness doesn't really hold up very well over time, so it eventually does let go, and then basically turns into like an oil almost, where it almost like the binder starts to come out of it. Um, so for that, you probably will want to grease the phasing gears on the back of the blower pretty regularly. I wouldn't say super regularly, but regularly enough. If you want to maintain the siren at least, like say once every couple of months or something. Which is actually kind of fun to do. But the blower itself, so the back gear case right here. So this is the phasing gear case. I would say that this is like again, there's going to be actually a little cap that goes over this hole. But the way I have it planned is that this cap will extend down from here and actually rests. If you notice, it meshes almost right in between where the gear mesh is. So that cap will basically be your grease applicator. So you'll pop the cap out of the back of the blower case. You'll have the little pin that sticks up from it. You take your grease, you put just a little dollop of it on top of the pin. You put the pin right back inside the blower, and that should be just enough grease to keep the gears nice and free and lubricated. That's my idea with it at least. So that'll kind of come out in the future during a maintenance video on how it's all supposed to work. Um, Additionally, like I said, there's no seals in here, so there's nothing to actually keep the grease in there once it's in there, other than just kind of its own viscosity. So you might notice that some of the grease has a tendency to leak out of the side of the case and then kind of get caught in between the blower frame rails, kind of in this general locale. But it really shouldn't be that big of a problem because it is silicone grease. It's not going to hurt anything. Um, Additionally, with that, so keeping on the greasing train here, we'll go ahead and go into the blower cabinet, or the rotator cabinet rather. So inside the rotator cabinet, you've of course got your rotator gears. Um, Again, very little bit of silicone, a very minor amount of silicone grease, just in between these gears, just to keep them nice and lubricated. Um, just basically to keep them, yeah, just keep them nice and lubricated so they don't wear very much because they are PETG. PETG is actually really not that bad for gears. If you want really good gears, you usually will use nylon. But PETG at slow or relatively slow RPM is fine. I really have not had any problems with PETG, even under high load. Um, so long as I built a winch that used PETG gears, but so long as it's relatively low RPM. Um, Now, don't get me wrong, you can turn the RPM, the rotator RPM, all the way up on the Thunderbolt. You're not going to melt these gears together. If the gears in the blower itself, which are also PETG, are able to hold up perfectly fine, I really wouldn't be concerned about it. It's usually when they're under high speed and high load, they start to try to weld to each other. So just keep that in mind. But yeah, keep these greased. Alternatively, another thing that you want to try to lubricate as much as you can is, if I can find where's this stupid rain collar? There it is actually in between the air pipe and the top of the blower cabinet shell. So there's a space right in between here. So if I go and I slide this up and down, so these two pieces are separate. What I would recommend doing with the Thunderbolt once you get it is to grease that section. All you have to do is remove the four screws in the Thunderbolt's the rotator cabinet, and then pull the head slightly out, and then you should be able to either push this piece up a little bit to get underneath it, and then just take a little dollop of grease and put it right in between these two pieces. So basically like right kind of in that little crack, and that should lubricate that shaft pretty well once that goes back down and actually sits on the rotator cabinet. So just keep that in mind. Another thing, so it's another grease point basically. And then finally, another place you want to make sure is greased properly is the bottom seat. So there's actually, this entire air pipe sits on a seat inside the rotator cabinet. Let me find the analysis to cut it in half. No, that's not it. Where is it? There it is. Okay. So here's the air pipe right there. That's the air pipe coming from the motor tube up very top and into the rotator cabinet. So if you can't, I'm trying to orient myself here so you can actually see kind of what I'm talking about. There's your bowl gear. That's what's doing most of the torque, most of the work right there. That is actually glued onto this air shaft. I haven't changed it yet to have the actual clutch there, but eventually we'll have a clutch so it slips. But this seat that this thing is sitting on, this little pedestal, you want to make sure that in between this air pipe and this seat, you maintain a very small amount of grease. That's basically just there to keep those pieces from wearing, because that's what's actually basically not only sealing the air pipe to the rest of the air pipe below it, but it's basically it's basically the bearing that the entire horn and everything is pivoting on is right down there. So I try to maintain a little bit of silicone grease in there to make sure that that's nice and slippery, and you should have no problems with that. Again, I would add that to your regular Thunderbolt 1000X Siren maintenance schedule. That's just one of the things you check. Alternatively, another thing you can do is that with the blower, to make sure that the air pipe is clear, I might even put a little drain hole on the bottom of this air pipe where water may collect, so that if the Siren ever does start up, this blower doesn't go and blow a whole bunch of air or blow a whole bunch of water out of the horn and into the motor and all that kind of crap. So I might put a little drain hole here on the bottom to drain this air pipe all the time. But alternatively, if that does ever become a problem, if you may start getting dust collecting in the blower pipe, what you can probably do is come over here, pop off the entire head from this little slip fitting. You can unplug it if you want to from the actual plug itself, but unplug the head from the air pipe, and then on your RCM, hit the blower test button just to run the blower to blow any crap out of the air pipe that may have collected. And that's basically what I'd recommend. But we're running on 12:17 now, and we're getting a little long in the tooth now with the actual chat and everything that we're talking about. So I guess it's about time that we kind of start wrapping everything up. A couple people have joined in a little bit late now. I do apologize for that, guys. I know you guys just got in. We're a little excited, but yeah, I gotta continue with my day too. And it's we've had some rain, but it's actually starting to kind of clear up right now. My wife's actually got a meeting too. We're running about 2 hours, So I'd say we're doing pretty all right. We're doing pretty all right. So, but with all of that, yeah, basically I hope everyone enjoyed watching. This was again a little impromptu. We kind of went over some stuff. It wasn't like a just chatting kind of stream. It was mainly trying to go over a lot of the stuff that we have going in. But yeah, Bristol HVAC has just got out of school. Darn. Yeah. Sorry about that. You can go ahead and take a look at the stream once it goes ahead and it uploads onto YouTube. But yeah, I hope it answered some people's questions. I'm probably gonna sit here and kind of sit here and mess with this a little bit more and get it all a bit more refined. Um, but yeah, I'll keep you guys posted. Most likely, probably posting some more stuff on my YouTube Shorts, so that'll allow you guys to see some of the tips, some of the teasers, some of the stuff that's kind of coming up, and get you an idea of what's kind of coming down the pipeline. Let you guys see some of the status of the Thunderbolt as it progresses. Um, Again, the giveaway is still ongoing, so people that have entered their names in, their names are now in the pot. I'm gonna go ahead and consider them in the giveaway, and that'll be kind of an ongoing thing. So I hope everyone enjoyed the video, enjoyed the stream. Thanks for everyone joining along and being here alongside with me. It's pretty cool. Is a 1003 expected in the future? Yes, I actually talked about that in the stream. So that's going to be logically one of the next sirens. But yeah, I hope everyone has a good rest of their day, and thanks for watching. All right, take care, guys.